Hi everyone, today I Anjali on the behalf of my team is going to present the group project which is sale forecasting that is based on machine learning algorithms. So let's start the discussion. First of all, let's start with the introduction part. As we know, predicting future sales for the company is one of the most important aspect of strategy planning. By predicting future sales, we mean that suppose we have few kind of attributes, or you can say the values, and using that values we can predict how much will be the weekly or monthly sale of a company. And here we will use machine learning techniques to analyze and predict the future values. Now for this project, what data set we are using? We're using, for the sales purpose, we're using Walmart data set from Kaggle. This data set is from, or you can say lies in the range from 2010 to 2012 and has 45 Walmart store data across the country. And apart from that, this data has these kind of attributes. First one is store. What is the store number? That we can say is a primary key kind of thing. Another one is date again. Like we are calculating the weekly sale using these kind of attributes. Then what would be the date? We can use first date, like first day of the 7 days. Another one is weekly sale. What is the data, like how much was the weekly sale of that given store? Now another are the attributes that will affect the weekly sale. Like first one is holiday flag. Like suppose if there is a holiday on that week, that will definitely affect the weekly sale, because like people tend to buy more on the days there where are they free. Or like suppose there is a special kind of festival where there is a holiday, so people tend to buy that kind of things that require on that festival. Another one is temperature. How is the weather of that week? Another is fuel price. What is the cost of fuel? Another one is CPI, that is customer price index. That how much we are talking about how much an average customer can buy, what is his capacity. Then another one is unemployment rate. Suppose if a company has much unemployment rate, that means that GDP would be less and there would be less sale on that country or on store. Now let's move to the objective. What is objective of our project that we're doing? First of all is to understand the data set. What are the attributes? What is the relationship between them? What is the relationship between CPI and the weekly sale, for example? So that we can understand what is the thought process of a customer, how things are going on, how we can, how the attributes are affecting the weekly sale kind of thing. Another one is regression. Using regression, we can predict the future sales. Now, what it means, suppose in the training data set, we are given the attributes, and corresponding to that attributes, we are given the weekly sale. So, for example, in future, if we have following attributes, what would the future sale that we can predict is called regression kind of thing. So that also we can do using machine learning algorithms. And now there are various models for the regression purpose. Now we will compare the different kind of models and will predict which one is working better using these kind of parameters like R2 or what is the error rate of that model, and compare these kind of things and compare which one is the better model. Now what is the approach for this? First one is analyzing through graphs. As we know, using representing visually is the best thing, that a person can understand what is going on. So here we are given two attributes. First one is the month, like in which month, and in the y-axis it is given the yearly sale. So we can say that, or say that in month July, how much sale was there, and the data is of 3 years, like 2010, 2011, and 2012. So using these values, we can conclude, or we can see that on the month December, there was a like huge maxima at 2010 and 2011, but in 2012 there was a dip. So maybe we can, using these, we can say that there was some issue in 2012, and we can find the issue and maybe work on that, and in 2013 maybe there is a more sales there. So maybe using these kind of things, we can analyze where things are going bad and where things are going good. Now talking about regression models, how we can predict the future values, there are few models that can be used, like linear regression, decision tree, random forest, k-neighbor, regressor, etc. Now first discuss about how like a brief overview of how linear regression works. Suppose these are the independent variables. Now what are independent variables? The things that, and what are dependent? Dependent variable is that we're finding, like we're finding the weekly sale that are dependent upon independent variables. Now what are independent variables? For example, the temperature, the CPI thing, the weather, how kind of weather was it, whether it was weekly holiday, what is the unemployment rate. So these are the independent variables. On that independent variables, our dependent variable weekly sale lies. Now we'll make a graph between independent variable versus dependent variable, and our coordinates would be there that are shown in blue color. So we'll try to make a slope or a line that is called line of regression, that will, or you can say, that tend to like, so we can say that tend to create minimum error, or you can say that lies near to the points. And for the future values, what we can do, we can extend that line, and if we have a for like, if we are given independent variables, using this line we can predict the dependent variable that lies near the line, and we can improve the model by like reducing the error rate as minimum as possible. Another model could be a decision tree. Now, how decision tree works? As the name suggests, it is a tree where like the leaves represent the whether the condition exists or not exist, and in the leaf there exists whether what is the output, or how, what is a dependent variable on the internal nodes. There lies the conditions, how is the condition and all. So let's suppose this is an example. It shows that suppose a person has interviewed for a company which has these kind of attributes, like what is the salary of that company, whether the office is near to home or not, whether there is a cab facility or not, and using that attributes, a person has to choose whether he should take the offer or decline it. Now, out of these three attributes, a person is sure that if the salary is less than 5,000, he is not gonna work there. So we can make a decision to like, using salary attribute, we can say if salary is less than this, just simply decline. And if it is more than that, then we can move to the next attributes. Then going to the next attribute, that is whether home is near to office or not. Now this is sure that if the salary is greater than 5,000, and then if office is not near to home, then he is going to decline it. And again, then move to the next attribute. So here what we do, we find the attribute that best say that if the condition doesn't exist, just drop it, kind of thing. So we'll choose the attribute where these kind of things happen, and we'll make the decision tree. Another could be same as like for the random forest decision tree kind of thing works same. If what happen, we make multiple decision trees using multiple training data, or you can using subsampling, and out of multiple decision trees, few results are there, and we choose the best possible result that came more times. Then what are the parameters that affect the model, or we can choose that which model work better than another. That one is like mean square error, mean absolute error, or R2 square error. Like mean square error basically measure the average deviation of actual result versus the predicted result. Same kind of things happen in absolute error. And R2 score is used to measure how accurate your model is. So using these kind of values, you can say you can compare which model is working best on these kind of which problem. Because different problems are, you can say it depends upon the problem which model is working better. Now let's move to the demo, how things are working here. So this is the demo of our project, sale forecasting, where we are using Jupyter Notebook to run the code. First of all, what we are doing, we are importing the libraries or the machine learning libraries that are required for this process. Again, we are using the walmat.csv file where the attributes and the weekly sales corresponding to it are given. So what we'll do, we'll use the data frame and using the pandas library, we'll read that CSV file. Now df.head command, what it do, it fetch the first 5 values by default, first 5 rows and all the corresponding attributes. So we can say that these are the attributes like store number, date, weekly sale, that is our dependent variable, and another attributes. So we can say the corresponding these attributes, this is our weekly sale. Now df.info, what it do, it tells us that how in the following attributes, how many null, non-null values are there, what is the count of it, what is the data type of it. So we can say that we can analyze if there is any kind of value missing. So here we can say that all values are all. So in this data there are 6,435 rows. So non-null values are there also. These are the same. So we can say there is not a single missing value there, which is a good thing, because sometimes there are missing attributes are there. So we need to perform further operations to handle these kind of scenarios. Now we are using this command to check like what is the count, or you can say how many values are there for each attribute, what is the mean of the values that we are given corresponding to each attribute, what is standard deviation, what is the minimum value, maximum value, etc., etc. Then what we are doing, maybe there could be a possibility that there is no missing value, but still there are null values in for any attribute. Like suppose for the temperature there is null value. So we also need to handle that kind of scenario as well. So what we're checking if there is any null value, we can get the sum or you can see the count of it. So from this we can say there is not a single null value there for every attribute. Now what we're doing, we are in date attribute, all the values are given, like what is the date, month and year. We are separating it out for the further operations that we'll discuss further. So we are making more attributes or more columns. Like now it is a day, it is a week, what is a month, what is a year. So we are making 4 extra columns out of the date column. Now maybe we can check the unique values. Suppose for this value, how many unique values are there for the holiday attribute, holiday flag attribute? Obviously two, one is 0 and one is 1. So using this we can check how many unique values are there. So using this command we can check. So as you see, for the holiday there is 2 unique values. First store it is 45 unique values because the data 45 stores is given to us. So you can say out of 6,435 values, 45 are unique values and they are repeating itself. Now we are importing the pie plot to plot the graphs. First of all, what we did, we checked the percentage of annual sales corresponding to each year. So from there we can conclude that maximum sale was there in 2011 and minimum was there in 2012. So we can say that we are degrading in terms of sales. So we need to look for the factors that are affecting it. Now another graph that we are using is visualizing. Index axis, there is store number. There is stores from 1 to 45 and corresponding to it, what is the weekly sale. So we can conclude that using these values, the store number 4 and store number 20 are doing great because they have the maximum values, and store number suppose 33, or you can say 44, or you can say 5 are need to work more to boost their weekly sales. Now this is a graph corresponding to day and the sales. So we from this we can conclude that on Thursday there is more sales as compared to another days. So we can again analyze what are the things that affect or how the sales are more on that day. Then there is a graph again with the week, like there is in the 1 year there is 52 weeks, so it is graph from 1 to 52 weeks, and it is in the y-axis there is weekly sale. So again here we can conclude that in the first week or in the 15th week or 28th week there were maximum sales, and in rest of the weeks there was less sale. So again we can analyze. Again graph with respect to month and weekly sale. So like in the month November there is less sale, in January there is less sale, in April it is more sale. Then the graph of each year versus weekly sale. So in 2011 it was maximum sale, in 2012 it was less sale. Now for better visualizing things, like you can't say in the month 7 you don't know what is the 7th month represent, either it is June or July or August. So what we're doing, we are mapping the values like 0 for the Sunday, 1 for the January, and also that we can easily visualize that 7th month represent the July kind of thing. Then what we are doing again, now what we are doing, we're calculating sales of where X represent the week and Y represent the weekly sale. Here, as I told you already in the example, it is a graph of 3 years which represent which month has maximum sale. So in December in 2012 there was a sudden dip, so we need to look what are the factors that you can see that was the reason of this sudden dip. Now it is important thing that is correlation matrix. Now what correlation matrix is, it tells us suppose these are the attributes, so these are the attributes for the values. Now what is the relationship between each attribute? For example, the relationship between year and store, or you can say weekly sale versus unemployment rate. It says that weekly sale versus unemployment has values as minus 0.11, which means that if the weekly sale is more, it is in negative. So which means that if they are inversely proportional to each other. If it is positive, means that they are directly proportional to each other, which means that if weekly sale is more, unemployment rate is obviously less. Either it can be opposite, obviously. If unemployment rate is less, which means that people can buy more things, so it would be positive. So they are inversely related to each other as value. The values lie always between -1 to 1. 1 means that they are purely dependent on each other. Now, in which case it would be 1, for example, for the holiday flag, or you can say for the year. Now, x-axis is year and y-axis also as year, so it would be 1 because obviously if year and year obviously purely depend upon each other. So for the, you can say for each corresponding attributes where x is equal to y, it would be 1, or and another there would be value lie between -1 to 1. Again the graph between how many holidays are there in out of all data, where the values is 0, it is huge, means that there was no holiday, and 1 represent there was holiday. Now what we are using, we will predict the future sales corresponding to given attributes using the various kind of regression techniques. So we are importing different kind of models. So what we did for the training purpose, What we did, we took all the attributes that are these attributes except one. That one is weekly sale, because it would be our output. Remaining would be input and weekly sale would be our output. Same thing we did here. For the training purpose, we took some values, and what we did, we use these kind of models, linear regression, random forest descent, k near neighbors and all, and we trained our model using these input and output values. Now what we did, here you can say we split the testing and training data, then we predictor you can say we trained our model using the training values, then we took the testing values and predicted the values. So it is a y predicted values, that is the weekly sale that we predicted. We will compare that predicted values with the actual values that are given to us, that is weekly sale. Then we'll calculate the R2 score, or you can say mean square error or mean absolute error, etc. And we'll compare these models. So here you can say for this model alien regression, these are the values. For the random forest, these are the values. We can compare mean square error, which model has less mean square error, means which is working better as compared to another ones. We can take these models and compare which one is best suitable for us. So this is all about the project, that is sales forecasting.